Assalamualaikum and a very good day. Today we arrive into our final chapter which is chapter 9, special topic chemical product design. So since this subject is designed for chemical engineering student, therefore this topic is very relevant. However, my specialty is in electrical engineering, so I might go through the slide literally as it is. So if you have any comments, you can put down or comments below, yeah. So we look into the introduction. So the chemical engineers who work on continuous chemical process normally run 24 hours per day for most of the years. So the specification for the chemical produced by the process were well defined by the unit operations under the control of chemical engineer. So this is all you guys, chemical engineering students, and you'll become a chemical engineer one day. The chemical engineer's role was disconnected from the ultimate consumer. So the capstone design class has traditionally involved design and economic analysis of such a process. So I believe in chemical engineering syllabus, you have a capstone design class too, right? However, the future of chemical engineering may not be in the traditional large continuous operating chemical plant. Rather, the future may be in the development and design of what can be termed chemical product design. Okay, so what is chemical product design? It's actually a new paradigm involving for the chemical engineers to explore more. Okay, it is more about product rather and materials rather than just designing the plant. Okay, designing the product. So Kassler and Mogridge and oh, it's so hard to pronounce their names, so maybe you can read. These people define 5 types of chemical products. So let us see what are the 5 types of the chemical product. The new specialty chemicals, products whose microstructure rather than molecular structure creates value, for example, paint. Devices causing chemical change, example, a blood oxygenator. Technology that uses chemical engineering principles, virtual chemical products such as software to simulate chemical processes or estimate physical properties. So what is specialty chemicals? Specialty chemicals are manufactured on the basis of their performance or function. They can be single chemical entities or formulation whose composition influences the performance and processing of the end product. The process in which specialty chemicals are created is called batch processing. What are some examples of chemical products and which company manufactures them? So some are Solvay produces surfactant blends that give shampoo and body wash a rich foamy texture. Okay, we have also Bimax, which makes a series of high purity monomers used for the manufacture of contact lenses. And the companies such as Nationfort Chemicals provide or produce pure grade sulfonic acid, which is used to make food dyes and among other things. So these are some of the companies and products. So we have here is Oleo Basic and Specialties. So we can have this Oleo Basics, fatty acid, fatty alcohol, and methyl ester and glycerines. These are the key products. We can see here the major applications and end market here. So you can see here, okay, the product here, which is glycerin. And now they're going into specialties, which is oil filled chemicals, drilling fluids, additives, which is used as emulsifier, lubricant, corrosion inhibitors, and cleaners. Okay, so the application is here. A few more example of chemical products. You can see here some of the example of the chemical product. In designing chemical products, there are a few technical issues in which chemical engineers must be familiar with. First is batch processing, and the second one is identifying customers' needs, then evaluating alternatives, estimating cost of prototype, manufacturability, estimating the cost of a product once it is mass produced. Okay, so what are the key difference between process design and product design? So the key difference between process design and product design is the entrepreneurial skills required of the engineer in product design. Okay, so you have to include the entrepreneurial skill. This must be so easy for your ITM student because you have one subject by itself, right? So strategies for chemical product design. The first one is identify customer need. The second one is generate ideas to meet the need, select among the ideas and manufacture. Okay, so the step one is identifying customers' needs. A new chemical product is sought in response to a need. So the need might be those of individual customers, those of groups, or those of society. For example, in the case of Freon refrigerant, in the 1980s, freons were identified as having high ozone depleting potential because of their chlorine content. Therefore, a need for an environmentally friendly chemical with the appropriate properties of the refrigerant was established. This led to the development of fluorocarbon refrigerants and methods for their synthesis. However, this did not solve the problem entirely. It was then determined that the new refrigerants were incompatible with typical compressor lubricants. This created the need for a new lubricant that was compatible with the new refrigerant. Subsequently, this new lubricant was developed, and the new refrigerant began to be phased in as freons were phased out. When a need is defined, it has to be precisely defined. Care must be taken to define the correct need. For example, consider the needs of vessels used for space travel. Example, the space shuttle, as they re-enter Earth's atmosphere. The customer, NASA, initially sought the development of material that would withstand the temperatures of re-entry. Such a material was never developed. Once the problem was redefined, a more appropriate need was defined. The real need was not to have a material capable of withstanding the temperatures of re-entry. The real need was to protect those inside the space vessel from the high temperatures generated by friction with the edge of Earth's atmosphere. This led to the development of the sacrificial tiles used in the space shuttle. The energy generated by friction is dissipated by vaporizing these sacrificial tiles, thereby protecting those inside the vessel from the heat. Only after the correct need was identified was the problem solved. Okay, that is an example. Strategies for chemical product design. A strategy for chemical product design has been suggested by Kassler and Mogridge. It has 4 steps. Okay, as we defined before, and we already identified the identify customer need. Next, we have to generate ideas to meet the need. So the second step is generate ideas to meet the needs. The generation of ideas is tantamount to brainstorming. Just as in brainstorming, when ideas are being generated, there are no bad ideas. Ideas gathered will be screened in the next step, which is selection. Ideas can be sought from a variety of sources, including but not limited to members of product development team, potential customers, published literature, consultants, even the competitors. Okay? Do not get married to an idea. Why? Because you get attached to the ideas. Okay? Because some of the ideas need to be divorced. Okay, so the third strategy is select among the ideas. So selection among the ideas. We look into, once a sufficient number of ideas has been generated, it is necessary to screen the ideas and select a few for more detailed investigation. first type of selection is by using criteria drawn by technical or scientific principle. For example, is thermodynamically impossible? If yes, reject the idea. If not, kinetically unfavorable? If yes, reject the idea. If no, more. We proceed to more selection criteria. So second type of selection is concept screening and concept scoring methods. So this is an example of concept screening. Okay, you give a 1, 2 screen and rank them. Okay, a positive or negative. Sorry, you give a positive or negative screening or 0 for maybe not available or is not related. Okay, so concept scoring, we give a weightage, okay, and times with the criterion. Okay, so the final selection, the final strategies for chemical product design is manufacture. Okay, so as we have reached this step, by now we should already have identified a customer need, have sought large number of ideas to meet this need, and have selected the best one of all two ideas. Okay, so the three aspects to be considered before we start manufacturing is, the first one is the intellectual property or patents. We make sure we didn't plagiate, okay? There's no plagiarism. And whether our step or method has been patented or not. Okay? If yes, we need to ask for the permission. Assembling missing information. The third one is environmental impact of our product. These are very important. So intellectual property or patents. Often new products will include some aspects of invention. The inventor if it is new aspect or new invention, the inventor has the right to seek patent protection, or not if they don't want to. Patents can give inventor the exclusive license to market his or her invention and hence command higher prices, which in turn let the inventor quickly recover from the development costs. However, in return of this exclusive license, the inventor must make full disclosure of the product details. So there's a pro and cons here. Okay. Assembling missing information, necessary to make sure our selected product will function as we expect. Also needed for patent application. Usually, information must be obtained from actual chemical or physical experiments, which are almost tedious. To save time, experiments have to be done as efficient as possible. So we look into environmental impact of the product. Involves making cradle to grave analysis of how the manufacture, use, and the disposal of the product will impact the environment. It is a complex assessment because there are many different criteria for environmental damage, including contamination of local river, pollutant discharge and landfill requirement, and global carbon dioxide output. Prior to proceeding with manufacture, we must satisfy regulatory bodies that any environmental damage caused by the product does not outweigh its benefit. In Malaysia, the product must comply to the Environmental Quality Act 1974. Okay. Manufacturing step consists of cost estimation, prototype testing, detailed product specification, how to manufacture the product, can the product be manufactured? Okay. So we look into cost estimation. A prototype is an early sample, model or release of a product built to test a concept or process or to act as a thing to be replicated or learned from. Prototyping serves to provide specifications for a real working system rather than a theoretical one. A prototype is an early sample, model or release of a product built to test a concept or process or to act as a thing to be replicated or learned from. Prototyping serves to provide specifications for a real working system rather than a theoretical one. Finally, is a conclusion. The challenges of chemical product design are different from those of chemical process design. These challenges include dealing with customer needs, screening alternatives, batch processing, and the need for interdisciplinary teams more than in chemical process design. So with that, thank you very much for all of your attention during the whole syllabus subjects of project management. Okay. Uh, can't wait to see you in class. Thank you.